When we talk about operations of functions, we're simply talking about ways to combine two functions using basic arithmetic. So that's addition, subtraction, multiplication, and division. Just like you can add or subtract numbers, you can also add or subtract functions, and you're adding or subtracting the outputs of each function. So if you think about it, the input would, if you have f of x, the input would be x, and the output would be all of f of x. So anything that's equal to this, so this would be where your expression is, you're just adding the two expressions of the two functions. So let's suppose we have the function f of x equals 2x, and we have the function g of x equals x plus 3. So to add these functions, we would write f plus g of x, or f of x plus g of x. And this basically just means you're adding all the outputs of f of x here, so you're adding this, plus the outputs of g of x, so you're adding this. So we take 2x and we just add it to x plus 3. And this is important to put the parentheses here, because later when we get to more complicated things, the parentheses will be very important. And since this is addition, you basically can get rid of the parentheses. So you can just do 2x plus x plus 3, and now we combine like terms. So you get 3x plus 3. So 3x plus 3 is our new expression, so that's f plus g of x. And now instead of using f of x or g of x, we can use this new combination that does both at once. So we don't have to add them together. This is our function for both of this. So the subtraction of functions works very similar, and we write it as f minus g of x, or f of x minus g of x. And once again, we take the outputs, so that would be 2x, and the order matters here, minus x plus 3. And remember the parentheses, because now it's very important, because that minus sign here actually distributes to both terms in the equation, so like this, because you're basically multiplying by -1. So you're adding the you multiply this by -1, and then you add it to the function, because that's basically what addition is. So we would do 2x plus -x, right, because you're multiplying, plus -3, and you can just get rid of these pluses. So you get x minus 3 would be our final equation for f minus g of x. Next, we can multiply functions. This is written as f times g of x, or f of x times g of x. And this means we're multiplying the two outputs together again. So we take the outputs of f of x, which is 2x, and the outputs of g of x, which is x plus 3, and we multiply them together. So we get f times g of x equals 2x times x plus 3. But we should put parentheses here. And so we don't even have to put the multiplication here, because parentheses automatically equals multiplication. And now we factor the 2x into both of the values. So we get f times g of x equals 2x squared plus 6x. And this would be the multiplication. That's all there is to it. And now division of functions is where it gets a little tricky, because we have to keep track of domain. So f divided by g of x is division, or we can do f of x over g of x. It's the same thing. And here we have f of x is 2x, right? So that would be the outputs of f of x divided by g of x. So we put here, and we put g of x down here. So that would be x plus 3. The outputs of g of x down here, so that would be x plus 3, equals f divided by g of x. And we can't simplify this further, so that would be our final function. But now we need to actually consider something very important. There's a division here with the x term on the bottom of the division sign. So that means we have to be worried about domain, right? Since there's a domain buster here. So we know that you can't divide by 0, so we set x plus 3 equal to 0. And minus 3, minus 3. So when x equals negative 3, the denominator equals 0. Which means we have a domain buster there, because obviously you can't divide by 0. So our domain would be all real numbers where x does not equal 3. And just watch out for division. Division is the weird one, because when you're dividing, you're creating another domain buster. When you're multiplying, adding or subtracting, you're not making another domain buster, so you don't have to worry about domain. If you don't have to worry about the domain of the function being different from the two you're adding, if your original functions don't have domain busters. The only time you can create a new domain buster, or a different or like a new problem you have to worry about, is when you're dividing, because you can get a domain buster that way. Here we'll be doing a more difficult example, purely because both of these, as you can see, both of these have domain busters because they have division signs, so we have to be careful of domain. And if we do division, we have to be careful of additional domain buster, which might occur. We don't know yet. So first we can start with addition, so we can do f plus g of x. So that would equal, we take the output of f of x, and we take the output of g of x, and we add them together. So you do 1 over x minus 2 plus 1 over x plus 1. Now this is a bit tricky because there are different denominators, so we can't just add the two functions. So what you can do is we can create a common denominator by multiplying this side by x plus 1 and multiplying this side by x plus 1 over x plus 1, because that's basically just multiplying by 1, and multiplying this side by x minus 2 over x minus 2. And what this does is it creates a common denominator. So we can first multiply this by x plus 1, so 1 times x plus 1 would be x plus 1 over, and we don't have to multiply it out because we can just keep it factored. This will actually be easier because when we're finding the domain busters, we don't have to factor it out again. Plus, now 1 times x minus 2 would be x minus 2 over, again, x plus 1 times x minus 2, and the order of multiplication doesn't matter, so these are the same. So now we can just add the numerators. So you get x plus 1 plus x minus 2. Make sure there's a parenthesis there, over x minus 2 times x plus 1. Now you may be tempted to actually to cross these out, but you can't because you have addition here. So you can't cross out anything. So now we combine like terms, so you get 2x minus 1, because 1 minus 2 is negative 1, over x minus 2 times x plus 1. And this would be our final answer, but we need to consider domain, and as we can see, there's x minus 2, there's x minus 2 and x plus 1 in the denominator, so if either of these equals 0, we have a domain buster. So the domain would be, we can just look at it and say, okay, x can't be 2, and x cannot be negative 1. So that's all real numbers where x does not equal 2 and negative 1. Now, moving on to subtraction, this is actually very similar because it's basically just you're subtracting, but you're multiplying g of x by negative 1. So you do f minus g of x equals, we get 1 minus x minus 2 minus 1 over x plus 1, and we can make this in parentheses. So we can do the same thing we did before. So x plus, I'm not going to explain this as deeply, times x plus 1, and then minus x minus 2 over x minus 2 times x plus 1. And here we must put the parentheses here so we can actually factor out, we can distribute the negative. So you have x plus 1 plus negative x plus 2. So now we just add, so you have x minus x is 0, that cancels out, and then 1 plus 2 is 3. So this equals 3 over x minus 2 times x plus 1, and this has the same domain as before because nothing changed in the denominator, where x does not equal 2 and negative 1. Now moving on to the more complicated ones, we can do multiplication, so we get f times g of x equals 1 over x minus 2 times 1 over x plus 1. And this is actually pretty simple for fractions especially, because you just multiply the denominator. It's easier than adding because you don't have to do any common denominator stuff. So you literally just get 1 over x minus 2 times x plus 1. We don't really have to factor this out, but we can just leave it as is, and the domain would be all real numbers again, where x cannot equal 2 and negative 1. Now finally on to division, we get f divided by g of x equals, now we get f of x here, 1 over x minus 2, divided by 1 over x plus 1. And this may look scary again, but we can actually just multiply by the reciprocal because that's the same thing as division. So we have 1 over x minus 2 times x plus 1 over 1. And this is quite easy because we just multiply these two and it's times 1, so we just get x plus 1 over x minus 2. Now here, this is our final answer, but if you look at the domain, we actually see that here it looks like there is less domain busters because x plus 1 is no longer in the denominator. So this function alone would just have x cannot equal negative 2, x cannot equal 2 as a domain buster. But we must also exclude all the domain values that make the original function, original denominator 0. So even though we we don't have x plus 1 in the denominator, we have to include it here in our domain where x cannot equal negative 1 as well, because we're combining these two functions.